Okay, this is lesson 6.1. These are the notes and examples for the first lesson in chapter 6, Relations and Functions. It says to describe the pattern in the mapping diagram, complete the diagram. We talked a little bit already about how the input is the x values and the output is are the y values. So when we're looking to describe them, we want to know how each one is changing. Looking at the input, it goes from 1 to 2, 2 to 3, 3 to 4. Okay, so each of these are increasing by 1. So we're looking at that change. As we compare then in the output, 8 to 10 changes by adding 2, 10 to 12 by adding 2. Therefore, if we were to keep up this pattern, we would be adding 2 each time, and we could fill in the boxes with 14, 16, 18, and 20. So to describe the pattern, we would say as the input increases by 1, the output increases by 2. Okay, the output is dependent on the input, so we want to word it in such a way that that's understandable. Looking at B, the input, again, is increasing by 1 and continues that pattern. When I look at 4/3 to 5/3, I know that if I add 1/3, I would get the answer. 5/3 plus 1/3 is 6/3. 6/3 simplifies to 2. If I have 6/3 and I add, oops, that's a 3, another third, I would get 7/3. 8/3, so I'd follow this pattern. When I get to 9/3, I could simplify it to 3, and finally 10/3. I would describe it as the input increases by 1, the output increases by 1/3. And this will help us later on when we're starting to write some function rules. Okay, so ordered pairs can be used to show the inputs and the outputs. Remember, these are the x values. These are the y values. I could take the ordered pairs and put them into a mapping diagram. And we list the inputs, we list the outputs, and usually go least to greatest, and we do not duplicate any numbers. And then you simply draw the arrow for which ones are paired up. 1, 2 to 4. So you could draw a mapping diagram, you could then take a mapping diagram and list the ordered pairs, which is what we're going to be doing next. So a relation pairs inputs with outputs, and a relation can be represented by the ordered pairs or a mapping diagram. And so this shows you both, and this is in your textbook. In the first example, we want to list the ordered pair shown in the mapping diagram. So 0 is matched up with 12, 2 with 10, 4 and 8, and finally 6 and 6. If you needed to, you could also graph them, but you're not being asked to at this point. So again, following the arrows, 1 has an arrow going to -1. It also has an arrow going to -2, so you must list both of those ordered pairs. So for each arrow there would be an ordered pair. You have 2 as an input and -3 as an output, and you have 2 as an input and -4 as an output. A relation that pairs each input with exactly one output is called a function. And this is an extremely, extremely important concept because not all relations, not all mapping diagrams of relations are actual functions. Looking at A, you can see -9 goes to 0. The input goes to 1 output. -2 goes to 5. It goes to 1 output. 5 goes to 10, and 12 goes to 10, but 5 only goes to 1 output, as well as 12. It only goes to 1 output. There are some mathematical rules that can be written where the output would be the same. Each input has exactly 1 output, so it is a function. Looking at B, -2 to 4 has 1 output. -1 to 3 has 1 output. 0 goes to 5 and to 6. So this is the part that 0 could go to 5 or to 6. What kind of a mathematical rule could we write that somehow pairs 0 with a 5 or with a 6? There's no rule that would allow us to do that. When you put that input value in as an x, when you substitute it into an equation and you do the mathematics according to the order of operations, you would get the same answer every time for that input. That's why it can only have exactly 1 output. There's no rule that we could write that would pair 0 with 2 different outputs. That is why it is not a function. So determine whether the relation is a function. Looking at the input -1/2, it is going to a 2 and to a 4. Right there, it's not paired with exactly 1, it has 2. 1/3 has 2. Therefore, this is not a function. Okay? Looking at 4, the input 2 has 1 output, 4 has 1 output, 6 has 1 output, and 8 has 1 output. That gives it the title of function. So let's describe the pattern for number 4. So this is increasing by 2, and this is decreasing by 3. So as the input increases by 2, the output decreases by 3. And finally, I just want to show you this to use the vertical line test to tell whether a relation represented by the graph is a function. So we already talked about the fact that to be a function, it's paired with exactly 1 output. So a couple things we could do. We could list the ordered pairs. So hopefully you can see that we have -2, 0, -1, 1, 2, 1, and 2, -1. If we were to draw a vertical line, you know, at all these places, and right here, it passes through 2 points, it fails the vertical line test. So this is not a function because it failed the vertical line test, because when x is equal to 2, when you have an input of 2, right, you have 2 different. 2 is paired with 2 different outputs. We had that positive one and that negative one. So looking at B, if we draw the lines, it goes through 1, 1, 1, 1. Each input is paired with exactly 1 output. Therefore, it would be a function. And it doesn't matter that it's not a straight line. We'll talk about linear and nonlinear functions in a future lesson.